show you something that looks simple but is actually one of the most complex engineering systems ever built. You open Netflix and you tap onto this play button, and the movie starts instantly. No lag, no buffering, it just works. But behind this tiny play button is an entire universe of DevOps pipelines, microservices, CDNs, caching, auto scaling, monitoring, and hundreds of engineering decisions running every single second. But before we go deeper, if you want real world DevOps with hands on labs explained in simple English, hit that subscribe button so you don't miss the next breakdown. Alright, let's start from the very beginning. What really happens when Netflix receives a movie? When Netflix receives a movie, it does not store in one big file. Because if one single file had to work on laptops, phones, TVs, tablets, Netflix would collapse. So the first step is the ingestion pipeline, a process very similar to checking in your luggage at an airport. Netflix will try to store the original video safely, and it will try to extract metadata, like for example, cast, title, languages, and breaks the video into smaller chunks and send it to the next stage called transcoding. One interview tip: if they ask, how do you support different devices and networks, your answer should be multi bitrate transcoding plus adaptive streaming. Now let's talk about transcoding. What exactly is transcoding? This is where Netflix performs engineering magic. Transcoding converts one single video into multiple qualities as displayed here: 1080, 720, 480, 360, 240. And inside each quality, Netflix generates multiple bit rates. Why? Why they do generate multiple bit rates? Because internet speed fluctuates a lot. Your TV is on a 300 Mbps connection. You'll get 4K quality immediately. But your phone on a moving train with terrible network might get 360 pixel. But the video will never stop. Netflix creates dozens of versions for every movie. One interview tip here: Netflix uses distributed transcoding workers that outputs multi-bitrate versions for adaptive streaming. Now let's jump on to the next interesting part, which is packaging and manifest. So once the transcoding is done, Netflix bundle all chunks and creates a manifest file. The manifest is basically a menu. It tells the Netflix player, here are all available qualities. Pick the right one based on the user's internet. Without this file, adaptive streaming wouldn't exist. Now comes the real DevOps part: CDNs. If Netflix streamed every video from their central servers, the internet would literally melt. So they push videos to servers close to you. These are called CDN edge servers. CDN edge servers. Think of it like restaurant. Instead of one very big kitchen serving the whole world, one big kitchen serving the whole world, Netflix keeps small kitchens in every city. Those small kitchens are nothing but our CDNs. 95% of Netflix traffic is served through CDNs. This gives faster playback quality, less buffering, higher reliability, low cloud bills, better global performance. Interview question: how Netflix handles global traffic using CDN caching plus geo routing and edge delivery. What is client playback? When you press play button, Netflix doesn't just play the movie, your device becomes a smart decision engine. It constantly checks for the network strength, device resolution, CPU load, battery level, Wi-Fi stability. Based on this, it chooses the best possible quality. This is called adaptive bitrate streaming. If your Wi-Fi becomes weak, Netflix instantly switches from 1080 pixel to 720 pixel. So the video never pauses. This is why Netflix rarely buffers. What happens during high traffic? When a massive show drops, for example, Stranger Things, Squid Game, Money Heist, traffic can jump traffic can jump 10 times more than the usual. So how does Netflix survives? Auto scaling. More traffic is nothing but more transcoding workers, transcoding workers, more playback servers, more CDN nodes serving content. When there is low traffic, then everything will scale down. Netflix saves millions of dollars every single day because of this feature. Here comes our monitoring and alerting. If you don't monitor your system, you don't have a system. Netflix monitors everything. Who's watching? What is the quality? Which region? CDNs failing? Buffering increasing? Playback errors? If one region has problems, Netflix automatically reroutes users to another CDN. This is why Netflix rarely has large outages. If this is helping you understand real world engineering, make sure you subscribe because this is the type of content I post every week. Now let's look at the cool part and very interesting part of this video, the demo. I am going to show you the mini version of Netflix on my laptop, which I built. So let's jump into the demo. This is how the folder structure looks like. I have a CDN folder, input folder, output folder, streaming folder, transcoder, and the docker compose.yaml file. So it is very simple: transcoder, streaming, and CDN. Now let's try to build our Docker containers. I'm going to run docker compose up -- build command, press enter. As soon as I run, it will try to create all the containers. If you see, it is also showing transcoding complete. Now I'm going to open the browser real quick. Now I'm navigating to localhost 8080 port. If you see, we have mini Netflix version. LearnWithDevOpsEngineer is my channel name here. And also if you see, we have playback at 720 pixel, 480 pixel, 360 pixel. We have different pixels. I can also play this. I recorded a small video, few seconds, because I don't want to waste a lot of time here. So you see the difference. I can play it in 480 pixel as well, 360 pixel. This is how the transcoding works behind the scenes. Now let's test the CDN cache. I'm going to jump back to my Visual Studio Code. And I'm going to request the same video twice, and I want you to watch how the cache responds. This is our first request. I'm going to press enter. Cache status is showing as miss as expected. That means the CDN did not have the file yet, so it fetched it from the origin. Now I'll try to send the exact same request again, and let's see the output. Now look at the output. It says hit. The CDN already has the video cached, so it serves it instantly. No origin request needed. This is exactly how Netflix offloads millions of requests from their backend. The more the CDN caches, the faster your playback, and the lower the load on Netflix servers. Let's try to run once again just to show you. It shows hit. Now let's try to recap everything we just built end to end. First, upload. Netflix receives the movie. Ingest. Video is chunked and metadata extracted. Transcode. Multiple qualities and bitrate generated. Package. Manifest file created and stored. Everything uploaded to storage. Content pushed to global edge servers. Playback. Smart players adapts quality. Finally, monitoring, real-time metrics and alerts. This is the same architecture pattern used by real streaming giants. You now understand Netflix better than 95% of engineers. And you can confidently explain this in any system design interview. If you want the next deep dive, how YouTube works, DevOps edition, just comment build YouTube next. And if you learned something today, hit that like button, hit subscribe, and stay tuned for more real world DevOps. Thank you for watching and see you in the next video.